All right, in this video, I'm going to talk about how to solve basic exponential model equations for growth and decay. So when we are growing exponentially, right, we've seen that kind of curve before, what we're going to do is we're going to take the rate as a decimal. So for instance, 5%, okay, we would turn into 0.05 or something like 1.7%. Remember, you move the decimal place 2 spaces. So that would become 0.017. If we're growing, we're going to add 1 to it. Okay, so like this first example here. Okay, we deposit $1,000 into a savings account paying this amount of interest. So again, let's move the decimal place 2 spots. Okay, so 0, so it's going to be 1,000 times 1.025. And then what we do is we put an exponent and we'll leave it as a variable. You could call it x, but we're going to call it t to help us remember that it's for time, right? Years in this case. Right, so when it says write a function, that's what we want to do. And really we should say like a equals or something equals to represent the final amount. All right, and then we're just going to ask you to do things with that model. So for instance, what is the balance of the account after 3 years? Okay, so in that case, we would want the time to be 3, right? So we're going to plug that in. So we'll just type 1,000 times 1.025 to the third power. And at this point, you would use your calculator or Desmos or whatever you need to use to find that, and you get about $1,076.89 if you round off. All right, we would also ask you questions like number 3, how long is it going to take for the account to reach $1,500? And so what we're going to do is we're going to take the equation and we're going to set it equal to that. Okay, so we don't know how much time, so we're going to leave that as a variable. That's what we're trying to solve for. And this is where you would solve using logarithms like we did in the past few classes. Okay, so that would lead me to this. Right, and then we would take a logarithm of both sides. I'll just go up here. Okay, so we would end up getting log 1,500 over 1,000. Of course, you could reduce that if you wanted to, and then log of 1.025. And again, at this point, you would use your calculator. Just give me a minute to do that. I end up getting about 16.4. And this time it would be years, right? So last time we found dollars, how much was in the account. This time we're finding how long it will take to reach a certain amount. Okay, so that's when we do growth. When we do decay, we're going to subtract from 1 instead of adding to 1. Okay, so for instance, this example, a cup of coffee contains 80 milligrams of caffeine, and over time the caffeine starts to be processed by your body and eliminated. Okay, and that happens at a rate of 16% per hour. So again, we will turn that into a decimal. So move it over 2 spaces, so 0.16. But instead of doing 1.16, okay, that would be if it was growing, we want it to decay. We want it to go down over time. So what we're going to do is we're going to do 1 minus 0.16. And you can type that in your calculator if you need to. You end up getting 0.84. Okay, and that's what we're going to put in our equation. So last time, 1,000 was the starting amount. Okay, this time 80 is the starting amount. And then the rate of change, right, is this number here, 0.84. So take it away from 1 rather than adding. And then again to the t. You can just say like the amount equals or whatever. All right, and then question 2, how much caffeine is left in the body after 5 hours? So you would just plug that in for time. Okay, and now it's just like the last problem. All right, and using the calculator, I get about 33.4 milligrams. Okay, so it makes sense that the amount of caffeine went down, right? We should lose caffeine. And then the last question is kind of similar to this one, right? We wanted to find when does the bank account reach 1500. This time we want to find out when there will be 10 milligrams remaining. Okay, so we're going to set it equal to 10 and solve. All right, so divide both sides by 80 and then set it up with logarithms. I'm just going to reduce it to 10 over 80 is the same as 1 over 8, right? So I'm just going to reduce it 8/4. Okay, and type that in your calculator. And I get about 11.9 hours in this case. Okay, so it takes almost 12 hours for the caffeine to reach that level. And that's it. That's today's lesson. So the ones in the assignment I'm going to give you are just like these problems. If it's growing, you want to do it like this. If it's decreasing or decaying or going down over time, then you want to do it like this. If you have any questions, let me know. Thanks.